again, what I was starting out saying is I think a lot of this today is called common sense. All right. And these are postulates, and sometimes postulates are called axioms. And remember, I was trying to discuss with you the other day about just things kind of like that two false statements is true. All right. These are postulates or axioms. All right. And it's just a postulate is a statement that is accepted as true without proof. In other words, believe it or not, there's things that we know are true, but we can't prove them to be true, or we just accept them to be true. All right. And these are a list of important postulates that I want you to kind of think about. I don't really think you necessarily have to write them down, but I think it's something that to me is obvious. All right. You see if it's obvious. If it's not obvious, then write it down. There are a list in the book. I just screenshotted this and put it up here. All right. So it's definitely right in the book. Same exact information is right there in the book. But let's see. First of all, it says through any 2 points, there is exactly one line. Now, why is this difficult? Well, I don't think that's too difficult, but why is there only one line? And so there is no proof to that. But just to make sure you're understanding what I'm saying, there's no way to get from P to R except one way. You can't do what? This is not a line. Does everybody agree with that? Right. Now, the next thing is I want to show you why, again, the definitions are hard. Because if I were to blow up on this, and now what I want to do is I want to try to make something really small. Does everybody see that line looks smaller than the line they have, right? And it still goes through those 2 points. Does everybody agree with that? So if I'm looking at this right here and I'm sliding it down a little bit, right now it looks like those points have thickness, right? So am I making too big of a deal of this? Does everybody understand what I'm saying? Right? We don't know the thickness of a line. We don't know a thickness of a point. It's just an idea for the most part. All right, does that make sense? So if you have 2 points, there's only what? One line that goes through those 2 points. That's what it's saying. All right. Now the next one is through any 3, and this is what's on the test generally. Through any 3 points, there's exactly one plane. If I say that, that's what? False. But if I say through any 3 what? Non-collinear points. And non-collinear points, remember, are just points that are not on the same line. So if I have 3 points, that will automatically create a what? Create a plane. So I agree with that. Now, can everybody see how, if I'm looking at the example above, that 2 points don't determine a plane? Does everybody agree with that? Now, if I added a point here, do those 3 points determine a plane? No, because they're on a line. Right? There's a lot of planes that go through that line. Does everybody agree with that? But as soon as I put a point not on the line, then it creates a what? Creates a plane. All right, hopefully that's making sense. All right. Now, to me, this one was kind of silly. A line contains at least 2 points. Because I always say a line contains how many points? Infinite, right? But here they're saying a line contains at least 2 points. Does everybody agree with that? All right, kind of common sense. All right, a line contains at least 2 points. I've always said it contained an infinite number of points. Now, next, a plane contains at least 3 non-collinear points. And again, I would argue a plane contains what? Infinite number of points. Does everybody agree? I think what they're trying to tell you is that in order to define a plane, you have to have at least what? 3. All right. To define a line, you have to have at least what? 2. Okay. Now, 2.5. If 2 points lie in a plane, then the entire line containing those points lies in that plane. And I just thought that made sense to me, right? If the line is in the plane, then the what? The points are in the plane. Does everybody agree with that? Again, does everybody kind of see what I'm saying is like common sense to me? Right. 2.6. If two lines intersect, then their intersection is exactly 1 point. You can't have two lines intersecting at two different points. Does everybody agree with that? Now, if two planes intersect, then their intersection is a line. And they're trying to show you that. If two planes intersect, the intersection is a line. Does everybody agree? It's not a point. All right. Now, a lot of times you might say, well, it could be that just that segment, right? But that segment, because the plane goes indefinitely in all directions, does everybody agree with this? Then that would be a line also. All right. That's easy. All right. Now, something that you already know is next, but it's just good to review. All right. It's good to review because you will be using this information to start some proofs here in a few minutes. All right. And again, very straightforward. An algebraic proof is a proof that is made up of a series of algebraic statements. And the following table summarizes several properties of real numbers that you studied in algebra. All right. Now let's just look at this real quick. The addition property. If A equals B, does everybody agree I can add the same thing to both sides and they'll still be equal? Yeah. Right. Again, not a big deal. Everybody look at those. Addition property of equality, subtraction property of equality, multiplication property of equality, division property of equality. All right, those are all things we use to solve equations. All right, and what do I mean by that? If I said, for example, x plus 2 equals 7, we know x equals 5 because we just used the what? We used the subtraction property of equality to solve that. We did what? We subtracted 2 from both sides. Everybody okay with that? Anybody have any questions? All right. Now, some obvious things that we are going to use in our proofs is something called the reflexive property. Again, you equal yourself. That's how I thought of this. All right. A always equals what? A. Yeah, it always equals itself. All right. Now, in math last year, I used the symmetric property all the time, but I just never told you it was a symmetric property. When you came up to something like 3 equals x, I always said to write it as what? X equals 3. And believe it or not, think of a long time ago, all right, before they had all this rules, before they knew 0 was a thing, right? Someone says 3 equals x, how do you know x equals 3? Correct? So in math, everything has to be in details. All right. You can't just say something anymore. You have to say why it's true. So when we say if A equals B, then automatically B equals A, that is called the symmetric property of equality. Now, the law of syllogisms, where we did yesterday. All right. This looks like the syllogism. And I think I said something to someone about the transitive property. All right. They asked me a question. Look at that. If A equals B, and B equals C, then A equals C. That's kind of like the law of syllogisms. All right, that's called the transitive property. And like I said, we'll be using these properties. Now, the substitution property, which we did a lot last year when we solved systems of equations. All right, if A equals B, then B can be replaced in any equation or any expression. A can be replaced by B in any expression or equation. All right, we've been doing that for a long time. And then, of course, the last one that we've done a million times is the distributive property. All right. Everybody okay with that? All right, straightforward. We're going to use those, all right, to do some proofs here in a few minutes. Okay, so now let's get to the homework. And of course, I don't know if I gave you time to write it up there. All right, but this is the homework. I forgot what page. I didn't put the page down. What is it? 156?
On the last part, it says 156.
Thank you, 156.
Okay.
Okay, it doesn't matter. It doesn't matter. All right, if you want to look, you can. All right, I just took pictures of it, so it doesn't really matter. All right, so here, let's try this. Now, again, the next thing every year, people ask me, do I have to write postulate 2.1, 2.2, 2.3? No, you don't. All right, you don't have to write any of that. Okay, I always just say through 2 points, there is one line. All right, you can write it out. There's no way to memorize that. Plus, if you look in different geometry books, the postulates are listed in different orders. All right, so just because it's 2.1 here doesn't mean it's universally 2.1 in every geometry book. Is everybody with me on that? All right, so you just have to kind of know those statements. All right, it's really super simple. All right, so here we go. Now we're just looking at this figure. All right, 1, 2, 3, 4, 5. All right, explain how the figure illustrates that each statement is true, then state the postulate that can be used to show each statement is true. All right, planes P and Q. It's not the right page. Yeah, I thought 150 was too much. So change it, 76. I'm sorry, guys. What is it? All right, let me find it. Well, just, it is what? 156. Everybody look at page 156. Is that right? About 156?
146. It is 146.
Is it 146? All right, sorry about that, guys. All right, page number 146. All right. So let's just make sure we're finding plane P. All right, plane P is this wall over here. And plane Q looks like this wall over here. So the intersection of two planes is a what?
Line.
Is a line. All right. So there you have it. All right. The intersection of two planes is a line. All right. The intersection of two planes is a line. Yes. All right, now let's look at number 2. Lines R and N intersect at point D. So I just want to find those lines. Lines R and N. Here's R. And here's N. They intersect at what? Point D. Just what they told you. All right. And the reason two lines intersect at a point. Two lines intersect at a point. Or I know it's kind of silly, guys, but they're just kind of getting you used to the terms here. All right. And making sure you understand they can only intersect at one point. What?
Where did you find that chart with all the things listed?
In that section. All right, number 3. Line N contains the points C, D, and E. Line N. All right, so let's find line N again. All right. Contains the points C, D, and E. All right, so that postulate is a line contains at least what? A line contains at least 2 points. All right, number 4. Let's find plane P. Again, plane P is the wall over here to the left. Do I agree with that? And that plane contains A, F, and D. A plane contains at least 3 points. That is true. A plane contains at least 3 points. All right, now let's look at what it says. Line N lies in plane Q. So if 2 points lie in the plane, then the line lies in the plane. All right, that's kind of what it's telling you. All right. Now I just want to make sure you're clear on this. And some of you really want to do well, so you're trying to be real good with your notes. I want to tell you that that I'm probably not going to ask you a question like that. It's probably going to be along the lines of true and false. All right, does that make sense? All right. I'm not going to make you write all those words out. All right. Yes. If you look back here, it says that if 2 points lie in a plane, then the entire line containing those points lies in the plane. You with me on that? Yeah. And again, you can abbreviate. You know, I'm not, memorizing is not something I'm trying to teach. All right. I think that's kind of common sense, right? If the 2 points lie in the plane, then the line containing those 2 points lies in that plane as well. All right, I think that kind of makes sense. All right, so now let's get into some more. All right, here we go. Always, sometimes, or never. I think these are appropriate for a test. If a plane contains a line and a line contains a point, then the plane contains the point. What do you think about that?
Always.
Yeah, I think that's always. Now, again, sometimes I'm telling you, I used to not be able to visualize very well. So some of you don't think, well, it's obvious for everybody else, not for me. It's not necessarily true. You get better at visualizing, right? So do we agree that if the plane contains the line, then the line is in the plane, right? And if the point is on the line, then the point has to be in the plane. I think that's always. All right, hopefully you can see that. A line contains 3 non-collinear points. That doesn't make sense, right? Now, again, I think the definition, understanding the words are important here. If there's a line, then all the points are on the line, which means they are collinear, right? So if a point's not on the line, it can't be collinear. So that's what? Never. All right. Line R contains only a point B. Never. Thank you. Never. A line has to contain at least what? A line has to contain at least 2 points. All right. Okay, now here's the kind of questions I like for 9, 10, 11, and 12. All right, here we go. So in the figure, ray AK is in plane P and M is on NE. State the postulate that can be used to show each statement is true. I don't know why I have that up there twice. Oh, I know why. I put it closer. All right, so we can look at it when I blow it up. All right, so now let's look. Is E in that plane, first of all? No. A lot of people didn't understand that. Okay. Is M in the plane? Is point N in the plane? Is point N on ME? All right, those dotted lines mean it's not on the plane. Does everybody agree with that? Even though it's drawn on the plane. And again, I used to try to tell kids all the time, we're trying to do a three-dimensional shape on 2 dimensions. It's kind of hard to do. All right, yes.
So like the line's going through the plane.
Yay, thank you, Lexi. The line is definitely going through the plane. And it hits at what? Plane N. It's kind of like my hand is the plane and the line just goes like that. That's what they're trying to demonstrate. All right. So now it should be easy to answer these questions. M, K, and N are coplanar. Now, again, I want you had to pay attention or you're going to miss it. M, K, and N are coplanar. True or false?
False. True.
Who said true? Tell me.
I said,
Because
Shh.
the three non-collinear must make a plane.
Yes, just because it's not drawn doesn't mean it's not true. That's why people bomb the next test, because they're not listening to me. All right? You don't want to be upset. Look up there and say, is the plane MNK drawn? It's not drawn. That doesn't mean it's not there. That's difficult. All right? You're literal, some of you. Literal. It's not drawn. Is it there? Can I draw a plane through those 3 points? There's only one plane that will be through those 3 points. All right, hopefully you're listening and hopefully you're not afraid to ask me a question if you don't understand something. Go.
But aren't M and N on the same line? So
Yes. So what does that mean?
nothing can be on the same line.
What can't be on the same line?
Nothing can be collinear to be able to.
I didn't say anything about collinear now. True?
Yeah.
Right? 3 points determine a plane. Now, that's a false statement. 3 what? Non-collinear points determine a plane. Do you agree with me? So if you just draw 3 dots, no matter where you put them, it's going to make a what? It's going to make a plane. Agreed? So there are 3 dots drawn, M, N, and K. Therefore, there's a plane. All right, what?
does coplanar just mean is it a plane?
Coplanar, same plane. Collinear, same line. That's what that means. Agreed? All right, the definitions, I understand. If you don't know the definitions, you can't play. Right? That's important. I never said definitions are important last year. Geometry, they're important. All right, here we go. NE, line NE contains point N and M. Come on, be brave. True. If you don't know that's true, you raise your hand and I demonstrate. If you know it's true, I don't want to waste any time. Everybody good with that? N and K are collinear. Now everyone's going to get it right. Why is it false? Why is it true?
Because the line
You
doesn't
can
have
sure no, because on the other one you said just because it's not there doesn't mean it's not true.
What is the rule?
the line doesn't have to be drawn.
The line doesn't have to be drawn,
Yes, sir.
right? The line doesn't have to be drawn. So 2 points, what? 2 points, what? Always determine a line. I don't care if it's drawn. That's difficult. I totally understand. That's difficult. You got to get used to that. Some of you are just literal. I was literal. It didn't make sense to me. All right. Draw the line. It'll be there. If you draw it, it's there. All right. Just because it's not drawn doesn't mean it's not there. Everybody happy with that? All right. And you're going to miss it if you're not listening. All right. What's next? Is it 12? N, A, and K are coplanar. Definitely true. 3 non-collinear points. All right, so I'm happy with that. Okay, what I want now is we never do flow proofs. All right, we call them 2-column proofs. All right, you call them 2-column proofs. All right, this is the thing everyone dreads in geometry. All right, and don't whine. All right, it's really simple. Every year, everybody whines about it. All right, you start out small. and you build. All right. Right now, we're going to do a 2-column proof. So here is your introduction. I just blew it up for you. All right. Complete the following instead of flow. We're going to call it a 2-column proof. So to do a 2-column proof, what you need is you have a list of statements and you have a list of reasons. This is why those buildings downtown stand. They've proven that they will stand. They don't just build something and say, well, we hope it stands, right? They know it is. All right, they know it is. They've proven it. They've done all the math. All right, and they figured all the, to me, it's amazing, all that weight, all the millions of tons is able to stand. All right, building bridges was amazing to me. How does that work? It's all math. All right, they figured it all out. And so that's what you can do. All right, this is just an introduction. If you're interested in, building things, you don't just draw them and say, go build that. They have to prove everything that you've done. All right, so now this is just the beginning. All right, so the first statement is always the given. So everybody's going to write down 5x minus 12 equals 8. And now the first reason is given. Step 1, it's given. That would be a good idea. Statement and reason. Every time it's going to be statement and reasons. Never a flow chart, never a paragraph. I don't write paragraphs in math. All right. We only do 2-column proofs. Now, 5x minus 12 equals 8. Why is that true? Because they told me it's true. All right. 5x minus 12 equals 8. Now, obviously, everybody here can say, just look at that and say x equals 4, right? But we're not allowed to do that anymore. All right. You would say step number 2. You would say 5x minus 12 plus 12 equals 8 plus 12. Why is that true? Tell them. And so what property allows me to say that? You have to tell me. Say it. No, we're not distributing anything. We're doing what? Marin? Addition. Property of equality. Now, listen, I just wrote that down for your benefit, but, well, let me just go ahead and do the long way. All right, so now what I want everybody to do is put 5x equals 20. I'm not going to make you do this that much. And this is called a what? Believe it or not. Yes, why is that called a substitution? Because what's negative 12 plus 12? 0. We're replacing equals. Does everybody agree? And what is 8 plus 12? 20. That's a substitution. We're replacing things that are equal. Does everybody agree with that? Right now, some geometry books call that simplifying. Do I care if you call it substitution or simplifying? I don't really care. All right, but if you look in some geometry books, it'll say simplify. Some geometry books call it substitution. I prefer substitution because you're substituting things that are equal. All right, everybody good with that? And now, step 4. 5x divided by 5 equals 20 divided by 5, and that's called what? Division property of equality. And so number 5, bless you. X equals what? 4. And again, if you want to, you can just say that's a what? Substitution. So there's your first proof. I don't think that was that hard. All right, you've been doing that this whole time. You just didn't know the names of everything. Does everybody agree with that? All right. Substitution, sorry. My pen's a little too big. All right, everybody okay with that? All right, here we go. Let's go to the next part. All right, now let's go down to 14. All right, now it says write a flow proof, and 15, write a paragraph proof. Are we ever doing a paragraph? I am not teaching you how to write, so we're definitely not doing a paragraph. All right, we're not writing a flow chart proof. All right, we are going to do what? 2-column proofs. Here we go. Notice I went ahead and just wrote them out for you again. All right. So here we go. If we want to blow up on this. I meant to write this in here. But that's okay. All right. Everybody got it written down? I know it's kind of annoying. All right, but here we go. Now, who's got statement 1? I'm listening. No, I'm asking about statement number 1. Now, it's not really a line, but we call it JK, right? Segment JK is congruent to segment what? KL. And then, of course, that's given. All right, so you always start with that. Now, again, there are technicalities in math that, you know, when I was in college, that's when I started doing a lot of good proofs. And if I accidentally wrote something, it was like automatically wrong because I'm supposed to know the difference. Well, I'm not as detailed right now because I'm just trying to show you something. But there is a difference between equal and congruence. Congruence is talking about shapes. Equal is talking about quantities, right? Does everybody agree with that? So when you want to change from congruence and you want to change to equal, that is called the definition of congruence. If something is congruent, then they are also what? Equal. Is that us really? Is that the end?
No way.
All right. So, man, I'm a little bit behind now. So that's okay. So listen to me, guys. I super appreciate it. We'll just pick up tomorrow, okay? Concentrate on what I said, all right? The only thing I really want you to do is 16 through 29. That should be no problem whatsoever. And let me work the proofs with you. So knock out 16 through 29. Man, I could just go on for hours. That's so sad. That went by really fast. All right, Lucas, hopefully have a great day, buddy. Hope to see you soon, man. Take care, buddy.